Hello, this is Ms. DB, and in this video I'm going to go over how to do some of the problems in your 4.3 worksheet on congruent triangles. Our objective is to use properties of congruent triangles and to prove that they are congruent by definition of congruence. And then you should have read this section in your book before you watch this video. So, triangles are congruent if they have the same shape and size. Their corresponding parts, the angles and the sides that are in the same positions, are congruent. So in order to prove that they are congruent by the definition of congruence, all the sides have to be congruent and all of the angles have to be congruent. So corresponding pairs mean that their corresponding parts mean that if triangle ABC is congruent to triangle JKL, then angle A is congruent to angle J because they're both listed first. So A is congruent to J. And then B is congruent to K because they're in the middle, B and K. And then C and L are congruent because they are both listed last in this congruence statement. So you have to be very careful that you are looking at the congruence statement and not just saying, oh, I think this one's congruent to this one because they're both on the left. That's not the way you do it. You have to look at these letters. So if you know that two triangles are congruent, you also know that their corresponding parts are congruent. And we'll look at a whole section where we do CP-CTC, corresponding parts of congruent triangles are congruent, in a couple sections. So here we have our first problem. It just says to identify the congruent corresponding parts. So you can do that by the way they're marked. It's kind of nice that they're marked for you. Or we could have done it from the way that the letters, the congruent statement is written. So we know that angle X will be congruent to angle N. Let's see, here's X and here's N. And yes, they are both marked with 3 tick marks. So that's over here. Angle X is congruent to angle N. Remember that you can use the less than sign on your keyboard in order to make a pretty close angle symbol. We'll call it good anyway. And so you also will go through and find the side lengths that are congruent. Name those with 2 capital letters. So NQ, let's find NQ. Here's NQ. It has 3 tick marks, and so does XZ. Now we also could have found that because NQ is the first and last letter of this triangle, the way it's named, and X and Z are the first and last letter of the way this one's named. So we should be writing this with a line over the XZ, but that's really tricky to do in Word, so we'll just write capital X, capital Z next to each other, or if you want to be specific, you can write segment XZ. All right, so next we will look at these two triangles are congruent, but they don't have all their angle marks yet. So we can write a congruence statement like I've been talking about. And then if the triangles are not labeled, you should label them in order to find which parts are congruent. So in this one, we have the triangles, the angles marked congruent, but we don't have our congruence statement yet. So the congruence statement, you might want to start with the angle marked 1, and then the one with 2 marks, and then the one with 3 marks, and then do the same thing for the other one. You could do it that way. Or you could just start at P and then go around. Or you could start with this triangle. So you finish up this congruence statement, which triangle is congruent to which, and then you answer. There's more than one answer here. How did you determine the order of your letters? Make sure that your congruent angles are in the same position when you write the name of the triangle. So we can use corresponding parts of congruent triangles and some algebra skills in order to find missing angle values or to find a variable. So what we'll do is, to save some time, we're just going to go ahead and start with one of your problems. So here we have 2 triangles, and it is given that these 2 triangles are congruent. Now the congruent marks are not on here yet, so you might want to start with labeling the angles that would be congruent and the sides that would be congruent. So we have triangle EFG is congruent to triangle RST. Oops, I have to get my pen tool here. Okay, so that means that angle E would be congruent to angle R. So let's find and mark those. Angle R is already marked with a right angle. If E is congruent to that, it is also then going to be a right angle. We also have that angle F will be congruent to angle S. F will be congruent to S because they're both in the middle of the name. And G will be congruent to T. So I'll mark those with a different number of angle marks. So then we also know that the sides, like side EF would be the same as side RS. So EF would be the same as side RS. And FG would be the same as ST. And then EG would be the same as RT. EG would be the same as RT. So notice that I used 1, 2, or 3 tick marks to show that I have 3 different pairs of congruent sides. All right, so the first thing that we're asked to find now that we have everything labeled is x. So we need to look at where is x in these two triangles, and I see that there's an x right here, and that is the expression for an angle. See the little degree mark? It's pointing to angle E, or it's telling me what angle E is. And angle E is congruent to angle R because I marked them both the same. They're both right angles. So its measure is 90. So you're going to write an equation, 4x plus 6 is equal to 90, and finish solving to find x. Now the next one asks us to find y. So y is over here, which is also an angle mark. See, it's got an angle thing. So it must be pointing to angle T. Sometimes it's a little tricky, so look for the angle marks to make sure if you know you're doing an angle or a side length. Side lengths won't have an angle little degree sign. So that's pointing to angle T, and we know that angle T is congruent to angle G because we already marked that. So angle T is congruent to angle G, so then you can write an equation that says that 5y minus 2 is equal to 28. And then here's another case where I'd have to put a few more lines in my Word document if I was typing this out, and then I would solve this equation for y. For measure of angle F is equal to the measure of angle S, but I don't know either of those, so that won't help me. I can't write an equation. But once you find measure of angle, I forgot what this one was, E. It's E. I covered it up a little bit with the arrow. Once you find the measure of angle E, which is going to be 90, then you can use the triangle sum theorem, the third angles theorem, or the triangle sum theorem to find the missing angle measure. So the triangle sum theorem is that this plus this plus this equals 180. I think that we'd use that. Or you can find, you can't really find measure of angle S yet, so I would use a triangle sum theorem there. And then there's one more question that goes with this, which is ST. And ST is a side length, and that is marked that it's equal to z plus 4, and it's also congruent to FG, which is 3z minus 8. So 3z minus 8 equals z plus 4, and then you can solve for z, and then plug back in to find the length of ST. All right, then moving on, number 12 is a similar problem, but without all of the hints and step-by-step things. So you have to find the value of x, which is a side length, and we know that triangle ABC is congruent to triangle DEF. So we know that angle A is congruent to angle D, they're already marked. Angle B will be congruent to angle E, mark those, and angle C will be congruent to angle F. We also know some side lengths are going to be congruent. Side AB will be congruent to DE. So AB is congruent to DE, and that would be enough to write our equation to find the value of x. Let's see if we already have enough for the measure of angle F. We know that angle F is congruent to C. So we could find the measure of angle C using the triangle sum theorem. because we know that A is 90, we know that B is 53, and we just need to know this angle, and the sum of those three will equal 180. So 90 degrees plus 53 degrees plus the one that we're missing, which is the measure of angle C. That will give us the measure of angle C, and then the measure of angle C is congruent to the measure of angle F. So that'll work out. In this problem, we know that BD, this is a shared side. Its reflexive property tells us that it is congruent to itself. So it's going to be, that side will be the same in both of them. We also know that angle A is congruent to angle C because of the congruence statement. We know that angle B is congruent to angle B. And we know that this is 90 degrees because it is a right angle for BDC, so then angle BDA also must be a right angle because they are a linear pair. And then you can also mark the congruent sides. We know that side AB is congruent to side CB, so AB is congruent to side CB. And then we already marked that BD is congruent to BD, and then also AD will be congruent to CD. AD is congruent to CD. So we have all the congruent parts marked, which will make it easier to set up the equations we need to find the missing angles. So to find the measure of angle C, we know that C is, the expression for angle C is x plus 11, and it is equal to measure of angle A, which is marked, no, it's not marked, is it? That is pointing to this. So 4x plus 10 is 90. Let's write that down. 4x plus 10 is equal to the measure of angle D, which is 90 degrees. We can use this to find x. 4x equals 80. And then we can use that to find the measure of angle C. So once we find what x is, then we can plug that back into this expression, and we'll be able to find the measure of angle C. So we had to find x before we could find the measure of angle C. Let's see if we can find y directly. To find y, we know that it's right here. It's the length of AB. It's part of that expression, y minus 7. Do we know what BC is equal to? Yes. So this one will be easier to solve. You'll just set the equation up and solve that. Okay, and then the last part is a proof. This is an example proof. These are some things that we would use some steps that we would use. Some of the things that we'll use for these proofs is things like right angles. All right angles are congruent to each other. We might use third angles theorem to find that, angle E is congruent to angle A. We might use definition of midpoint if they tell us that we're given that C is the midpoint, which means then that DC is congruent to, is that a C or a G? It's a C. To BC. So we'll use things that we've already learned about in our previous chapters and use those to go through and make sure that all the angles are marked congruent or found congruent by one of those things, and that all the sides are congruent. So the definition of congruence is that you have to show that all pairs of angles and sides are congruent. So there'll be a lot of steps in these proofs. But the good news is that in the next lesson, next week, we will learn shortcuts that we don't have to have every single part being congruent. So on 15, here's lots of given information. Let's see if we can mark anything in addition to what they already have. They have angle Q is congruent to angle R. They already have that marked, okay? They have that P is the midpoint of side QR. P is the midpoint of QR. Well, that's not marked yet, but that means that if it's the midpoint, it means that QP will be congruent to QR. So we're going to be using that here. P is the midpoint of QR. That's a given. And the definition of it being the midpoint tells us that QP is congruent, segment QP is congruent to segment PR. Because that's what the definition midpoint says. We're also going to use vertical angles somewhere. Vertical angles tells us that if you have two lines crossing and forming this X, that these two angles across from each other will be congruent to each other. So when you write that angle NPQ is congruent to angle SPR, the reason will be vertical angles. That's going to be right here. Angle N is congruent to angle S. How do we know that? If we already have that angle Q is congruent to angle R, and now we just use vertical angles to say that another pair of angles are congruent, how are we able to say that angle N is congruent to angle S? And the reason is the third angles theorem. I don't think I used that in the example proof, but we use that in a lesson in chapter 4. The third angles theorem says that if you have two angles that are congruent to two angles of another triangle that are congruent, then the third angles will also be congruent. So this will be because of the third angles theorem. And then you've got some given information, and then your reason for these two triangles to be congruent. If you've already shown that all the angles are congruent and all the side lengths are congruent, then your reason for them being congruent will be the definition of congruence, or the definition of congruent triangles if you want. All right, that's it. I went a little bit long, but I hope that helps. Please let me know if you have any questions.